We've been working on this machine for the last couple of weeks. We got it up and running, added some additional RAM and this second internal disk drive in the form of a Gotek. Now though, it's time to think about a hard drive. All these machines do natively support a hard disk through this port on the back. A 19-pin D-sub, commonly known as the ACSI port, or Atari Computer Systems Interface. Now, back in the day, Atari did sell large external hard drives that you would have plugged in there, giving you, I think, up to 40 megabytes of available space. These days though, there are more modern solutions, and the one that I want to try and put together today, it is in here, and that's an ACSI2STM. Gary over on the CRG Discord, he did a wee group buy of these recently. So he sent us a board and a load of parts. Let's start by putting it together. All the components have been laid out on this bit of cardboard, labelled numbers 1 through 23, and there's the board. But that's not the only thing that Gary sent, because also in the envelope, a bill of materials, which references all the parts against the ID numbers. We have a letter, which is also another bill of materials. Hi Glenn, included a couple of other PCBs for you. We'll get to that in a minute. Hope they are of some use. Yes Gary, they most definitely will be. Thank you very much. Not really sure what this is. We have a syringe, an empty syringe. And these just must be some of those boards that he said were included, because there's those bits and then all these. We'll maybe take a closer look through all this at the end of the video. For now though, I really want to get this put together. He has stuck something to the PCB here. I have a feeling this will be the little controller, and yeah, it does seem to be. An STM32. And I suppose since I've got it out here in my hand, let's just start with that. Goes on that position there, pin 1 indicated by the dot on the silk screen, and equally by a dot on this package. I need to put that on something like that. So that's the silk screen pin 1 marker, and there's the pin 1 marker on the chip. I'll just drop a bit of flux in one corner here. I'll just stick a little bit of solder on the tip of the iron, and let's see about getting it stuck down. I think we got it there. Yep. So we'll spin it around and do a pin in the opposite corner. Just the same way. And that should be the chip anchored. So there's no description on this for any particular order in which we should be doing things, but I think what I'll maybe do is all the very fine stuff next. All the passives, the resistors and capacitors. Those are incredibly small. Some of them in particular, that one there, R11, that looks as if that might be 0402 footprint. It is tiny. And yes, you're not the only one thinking that I maybe should have done them last, because some of those other caps right beside them and resistors, they are 0402 components, and now these things are going to be in the way. But let's just struggle on. And I can't get it stuck down. I can get solder to go on absolutely everything apart from the point that I need it on. Definitely made a mistake putting those larger caps on first. That's it on, but that was next to impossible. So I think we're going to change the plan slightly. To do the rest of the 0402 stuff, I'll try using some solder paste. And ideally I would have a stencil for this, but I don't. Just want to see if that worked or if they're possibly shorted. That one's alright. And that one's okay as well. So I think that's just how we're going to have to do it. And yeah, let's concentrate on getting all the 0402 stuff done first. Well, that one just went ping. Thankfully Gary included the spur, because that is gone forever. I think that's it. All the 0402 stuff is on. We will check it all under magnification at the end, but I can honestly say I will never work with that stuff again. That is not meant to be done by hand, or at least not meant to be done by hand by me. The rest of it will hopefully be fairly straightforward, but we'll try to continue going in order of smallest to biggest. So next thing I think will be the two LEDs that go here and here. Now obviously the LED has a polarity, and it's funny that they've used two different symbols here for the two different LED positions, but in both cases here the negative is to the right. The line sort of in the middle of that T there, you might say, that's pointing towards the cathode or the negative side. Same with that one, the point of the triangle pointing to the right, that's the cathode. On the component itself, you can see one side of it there has a bit of colour in it, there's a bit of green, that's the cathode side. So that needs to go on like that. LEDs are subjective to heat though, these surface mount ones, so you don't want to overheat them. You can sort of tarnish the top of them, you can burn it quite easily. We'll do item 20 next, which is a voltage regulator to go at position U1. 3.3 volt regulator, that will be providing power to this. I think that leg of it there might have shorted to that cap. Well, a little bit of flux and a quick reflow should hopefully sort out any issues like that. Last surface mount component then is the crystal. Looks like there's options on this to fit two different types of crystal, either position X1 or X2, and Gary has included the one suitable for this position. Then it's just really sockets. We'll do the USB-C socket first, it goes on there. That will be providing 5 volt power to this board. We don't power this from the Atari. SD card slots. There is space here in the middle of this for a battery holder. So just a lot of pin headers to do, they're all going to go on there. I'm not going to fit this, and equally not going to fit this. This one I believe is intended for an ultra Satan, possibly for a pass-through. I think you would fit this on that side of the board. Then you can attach a ribbon cable to that to go to your ultra Satan, but I don't have one of those, so don't really see the point in fitting that. This one is just to go on there for the programming, but once it's programmed you won't need that, so we can just wedge something in there to do that. All these ones though, these actually make the connection to the ST itself, and they go on this side because it plugs in like that to the back of the ST. And I was wondering if we just could have used a solid strip rather than these individual sets of 2 pins, but we can't because that doesn't line up. So not much choice but to use all of these. The fun bit will be getting all these orientated correctly. It's obviously been spaced out so that it lines up with the holes on the back of the ST. In fact, I wonder if I should stick that into the ST and then solder it up that way. And yeah, I think that's going to be a better idea. And in fact, yeah, I think you'd almost have to do it like this, because if I try to push that in home there, the card is almost sitting at a bit of an angle. So it almost wants to be positioned something like that, where just the bottom of those pins are protruding through there. I can just then carefully push all those black bits down flat onto the PCB. And that should do it. Interesting that the pin at position 15 isn't used in this. Wonder what that does. Pin 15 is just a ground, same as 17, 13 and 11, so it does no harm leaving that one out. But otherwise that is it built, so time to program. Or in fact, maybe before we do that, let's get the microscope out and inspect it, just to be sure that we're happy with all the solder work. Give it a quick clean, just with a toothbrush and a bit of IPA. So let's bring in this thing and take a closer look. So starting at pin 1 of the STM32. All looks okay. Yep, happy enough with that. Bit of flux still underneath that chip. Probably wants another quick clean. Some of those pins there maybe a bit suspect, are they? No, they're okay. Although that potentially looks like a cold solder joint there. So it's just a dull colour compared to the rest of them. And even around that capacitor there, that was put on with a solder paste. That might just want reflowed quickly. But working our way around the rest of that chip, again, that capacitor there, C3, the solder on it is just a funny colour. But the rest of that all looks okay. C5 there isn't positioned particularly well on its pads, but I mean, it'll be fine. And that other side, that's okay. Just going over some of the other components quickly. Yeah, that all looks grand. What about the USB socket? That all looks pretty good. There's the voltage regulator. I was worried that pin might have been shorted to that cap, but it's not. But all the solder points on the SD card slots, they all look pretty good. Capacitor C11 there. It's not sitting particularly well. I mean, it's soldered in place again, but I might just reflow that quickly. What about up at the LEDs? That resistor's not sitting great, but I think I'll have to do. Very hard to get the iron into that now. There's that green mark I was talking about on the side of the LED. That's the cathode side. Same on the other one. So yeah, it's not looking too bad. Some of those caps probably could be positioned a bit better. Although I wonder, is it even worth worrying about it really, because everything does seem to be attached. There doesn't seem to be anything shorted anywhere. Maybe we should just leave well enough alone. I did want to try and reflow one of these, that corner there. I wanted to try and reflow that, didn't I? Yeah, I just think that looks a bit better. Slightly better colour to the solder joints there. That cap there was a bit iffy as well, wasn't it? C3. Although it's sort of just staying that dull grey colour. Maybe that is just how that solder paste goes. Yeah, maybe we should just leave well enough alone. Let's get this programmed. It's fairly simple using one of these things if we just follow the instructions over on the GitHub. So this quick start guide section, we can just sort of scroll down through all this because we've already ordered the boards, we've already built the thing. What we want to do is flash the firmware. So it gives us the pinout here. It's also written on the silk screen of this. And granted, the images that they show you there are of two slightly different programmers from my one. For mine though, I've just wired up these DuPont cables to this 6-pin header here that I'm just going to stick down through there. We'll hold it in place with a bit of tension. When it comes time to program, that should be enough. The only thing you need to remember when hooking one of these things up, when wiring it up like I have, is that you need to cross over RX and TX. But we just download the latest firmware. We get it from this page on the GitHub. At the time of making this video, the latest stable version is version 5, so just download the zip file. I've already done that and extracted it onto the hard drive of my computer. Then we want to run this bit of software. I have it open here, so we will plug this in to USB. And just hold that there with a bit of tension now. We need to change this from ST-Link to UART. You need to select the appropriate port for your programmer. Mine is on COM5 and connect. And no, it's not liking it. I wonder, do we have a dodgy solder joint somewhere? Or maybe it's one of these wires, because these aren't great. Don't buy cheap 2-punk cables. They always give you nothing but problems. Right, we are successfully connected this time. So then it's just open file. And in the firmware folder, it is this one that you want. Then we just download. And that should be it. Never underestimate the stupidity of a retro tech YouTuber. So I said that there was 2 positions for crystals here. That is correct. But I thought it was maybe giving us options for different types of crystals. No, that's not correct. This one is an 8 megahertz crystal, which is running the board. But this one is a 32 kilohertz crystal. This is for the real-time clock. And sure enough, Gary did include it. There it is there. Number 1. I just didn't see it because of the clear packaging. More haste, less speed required. And let's test it. You can see I've stuck a battery in there just for the real-time clock. But we'll plug this into the back. We need to plug some power into it. And it's obviously going to need an SD card. I just have this old 4 gig card. I think that'll do us. Should be plenty of storage for this machine. The one thing we're going to need though is a driver. Because while all the STs do have a hard disk port on the back, the one thing they don't have is a hard disk driver. Now there are a couple of options out there. There's a free one which supposedly works but maybe doesn't work that good, and there's 2 paid ones. One of them, originally enough, called HD Driver, and while I'm sure this one is quite feature rich, it is also a bit pricey, coming in at either 49 or 69 euros. So instead I have opted to go for the PP hard disk drivers, or the Peter Putnick hard disk drivers. That's the name of the guy who created them. He sells 2 versions of this, either the basic version or a version that has a virtual floppy drive support. We don't need that because we've got the Gotek, so I just went for the basic version. It is 23 euros or £19 and change. So you just transfer the money to Peter. He sends you a couple of zip files containing these bits and pieces, and within this we have 2 versions of the driver. Version 1.01 or 1.03. Now in this folder for version 1.01, he has very handily included an ST disk image. I have that on our USB stick, so we will stick this into the Gotek and let's try and boot to that and set up our drive. So I don't know if you noticed that there, but as it booted up, it gave us some information about the ACSI2STM, and I'm not sure it looked right because it listed SD slot 1 and SD slot 2. It didn't list SD slot 0. But let's go into our floppy disk anyway. That file there is the driver, but the one we're interested in is this file. This is the partition program, and our drive is sitting on ACSI device 0. Is that how you pronounce that? ACSI? ACSI? I don't know. So we just click on that, and there it is. Although that also doesn't look right, because it's saying their drive size is 2 gigabytes, but that's definitely a 4 gig card. And in fact, down here in this sort of grey bit, you can see that it has correctly picked up SD0 raw 4 gigabytes. But look, let's just try and create a couple of partitions anyway. The maximum partition size we can have is 512 megabytes. We'll just create 2, drive C and D, and partition and initialize. That seemed to do that very quickly. I'm not convinced that did anything at all. It did flash the access LED on our card there, although I'm not even sure you can maybe see it. Let me just adjust this. Hopefully you can see it now. You can see it did flash that for a second. It just seemed to do that very quickly. If we exit out of this, well, the hard disks have not appeared. A little bit of reset. No, that still doesn't look right. We don't have any hard disks. Something here is not happy. Right, I've been screwed about with this. We now also have a disk image for version 1.03 of the driver. I need to say thank you to Mike over on the CRG Discord for making the disk image for me for that. But if I try to run this as well, I need to change to medium screen resolution. Well, we can run the same partition program. And again, it's not detecting that properly, or at least I don't think it is. Still says that drive size is 2 gigabytes. It's not, it's 4. We can still see that it's 4 in this sort of grey bit. And it doesn't detect those 2 partitions that we made last time. We can try that again. But yeah, I'm not convinced that's doing anything. Let's try a reset. See, at that point, I think it should be showing us SD0 on the SD card. But it's not. If we run that driver file, that's meant to install the hard disk driver onto your hard disk. But it's obviously not doing anything. I wonder if we take the SD card, stick that in here and drop it into Windows. Disk management. Yeah, there's that SD card. No partitions created. Well, I've been screwing about with this and not really getting anywhere yet. But on the back of it, you can see I have tried installing a few extra bits and pieces. So there were positions here for various jumpers that I didn't bother installing initially because I didn't think we'd need them. This 4-pin one is for selecting the ACSI ID that is addressed to these different SD card slots. In its unpopulated arrangement like that, it sets them as 0, 1 and 2. You put the jumper on to move it to 1, 2, 3 or 2, 3, 4. And I did try that, but it didn't make a button of difference. Speaking of buttons, I installed that one. That's at a reset jumper. I thought maybe if we powered on the ST and then tried resetting this card, maybe it would detect the SD card properly, but no, again, didn't make a button of difference. So this last one here is J13. That's labeled strict. And if we close that, it puts this thing into what seems to be called a strict ACSI mode. Does that force it to perhaps behave more like an original Atari hard drive? I'm not too sure, but it is going to be the last roll of the dice. So we'll plug it in again and try it. Future CRG here, just interrupting for a second, because at the time of originally recording this, I didn't appreciate that our card here, it supports a couple of different functions. So without this jumper in place, as I was originally trying to use it, this card is expecting you to put Atari hard disk file images on the SD card. Those are hard disk images like you would use with an Atari emulator on your PC. That's not how I want to use this though. I want to have partitions on the SD card. I want to write the files directly to this. And so for it to work like that, we need to close that ACSI strict jumper. That makes this thing behave as if it was just a hard drive. And that's why it magically starts working as you're about to see. So we'll just go into slot 0 again with our 4 gigabyte card. And we'll stick the USB pen in. Let's go back to version 1.01 of the driver. We're in gem already, so let's try our partition program again. ACSI0, and yeah, that looks right. 3,759 megabytes of SD card. That sounds about right for a 4 gigabyte card. So let's try creating the two partitions again, 512 and 512. Partition and initialize. Yeah, that's taking a bit longer this time. That seems right. Exit. And let's go for a reset. But no partitions. Oh dear. What happens if we try and load the driver? Okay, it's asking us where we want to load the driver. So let's put it onto 0. Install. Go for a reset. This time it has seen two partitions. There it is. C, hard disk. Where's D? I think to get D, what we need to do is mount it manually. So we'll select that, options, install disk, D, and there it is. Yeah, there are the two partitions. Fantastic. So I don't think we need that anymore. Let's power this off. I'll take the SD card and move over to Windows again, and let's try and copy some stuff onto it. So it's interesting there that Windows is only seeing the one partition. What about in disk management? No, well, it sees two partitions on the SD card. Maybe what we need to do is assign a drive letter to it. There we are. I can access it now. Hopefully that hasn't screwed things up for the ST. Because what I want to try and do is, let's put a couple of demos onto this second partition. Let's put a couple of games onto this first partition. I have downloaded a few bits and pieces here. So we'll go with Canon Fodder. We'll have to try Frontier. And how about Alien Syndrome? And for demos, I'm not really sure what these are. I just grabbed them off Puet. And okay, that's 3 demos and 3 games. So let's stick that back in there. Power up. It's detected our 2 partitions again. And it's booting to C. There it is. There's our 3 games in C. What about drive D? We're going to have to install the drive again. In fact, I think what I can do, let's also change that to medium resolution just because it looks a bit better. I've lost drive D again. I think ultimately what I need to do is move to driver 1.03. But if I save the desktop at that, and if we reset again, are both drives there this time? Yeah, they are. And in that drive C, or drive D, sorry, yeah, there are the 3 demos. But we'll start with a game. And how about we try a bit of Canon Fodder? The Amiga Classic. What's it like on an ST? So that's pretty cool. It seems we have a shortcut to exit the game, the star button on the number pad, and we can also save a game state, save states. That seems pretty cool. And there it goes, playing the iconic music. Although it doesn't seem to have the rest of the intro that the Amiga version would have. Let's just get into the game. So I wonder if that flashing image there, I wonder is that maybe a sign of insufficient RAM in this machine? Because remember, we've only got the 1 megabyte total there. And I know from experience, with the likes of WHD load games on the Amiga. If you're trying to run one of those with a minimal amount of RAM in that machine, it can't do that. The screen can't flash just while it's loading additional assets of your hard drive. But it's Canon Fodder and it is otherwise working. Fantastic. Let's try another one. Let's try a bit of Frontier. This time it seems we're not going to get the game X, which I assume is a game exit key. Because for this game, for that, we need a minimum of 2 mega RAM. And yes, running on the ST with its slightly faster 8 MHz processor when compared to the Amiga 500 and its 7 point something megahertz processor, this intro does feel ever so slightly faster on this machine than it would on the Amiga. But we've seen it all a million times before, haven't we? The other game that I stuck on the hard drive is Alien Syndrome. We'll give it a quick go. And then we'll maybe run a demo. Quick key this time is F9. We'll take the female character. Not that this in any way is trying to rip off Alien or Aliens. Very good game, even though I'm not very good at it. I think originally this would have been a twin stick shooter. Yeah, really not good at it, I'm dead. But on the Atari here, it's just a single joystick and the button is fire. The demos I put on drive D. I have 3 of them here. Let's just run this one. Oh, and I don't have enough memory. Hey, after a hard reset, it's working this time. Nice graphical effects. Not too sure about the music in this one though. I wonder would these other ones work now? Yeah, this one seems to be working as well. And that music sounds a bit better. And I've just noticed my Gotek is now doing weird things. What is that all about? Yeah, why is the screen not working on the Gotek? That is strange. Because I powered off there, then pushed that reset button that we fitted on this thing. Powering on again, and this now works. So is there something between there causing a little bit of confusion, upsetting that screen? I couldn't see how that would be possible. I'll have to keep an eye on that. Just want to see though if I can run this last demo. And no, that one must require more memory still. So to finish off, I said we'd take a look at some of these boards which Gary had included. Atari VGA adapter, PS2 adapter, I just need a PIC chip and programmer, Amiga USB-C PSU, Amiga status LED board, Atari diagnostics board, and a Necroware Dallas board. But there are a couple of other bits and pieces in here as well, such as an IDE 68K, one of the first boards that we actually built here on the channel. That sits underneath the CPU in your Amiga, giving you an IDE port. A Blue SCSI, version 1 I believe, version 1.1, sorry, fantastic little device. I do have a couple of these already, so if Gary doesn't mind, what I'll do is offer this up. If anybody wants this blank PCP, just get in touch and I'll send it on to you. And then there's this one, which I don't believe was mentioned. Not really sure what this is, but one oddity about it is that all the writing on it is backwards. Absolutely all the writing is backwards. Some sort of controller I see on it there. That says USB, left, right. Rotary encoder. Is this a floppy emulator of sorts? Is this like a Gotek? A blank PCB for one of those? That would be your floppy connector there. There's power there. Yeah, I think that's exactly what it is. But with all the writing being backwards, it sort of make me wonder if this has been manufactured correctly. Because if somehow the PCB has been mirrored when it was manufactured, well, that would explain why all the writing's backwards, but it also wouldn't work. So I'll need to do a bit of homework on that to see if this is usable. There's the other boards that were mentioned in the letter. VGA adapter for the ST, although it is just taking the RGB signal from the ST direct to VGA. Looks like we have trim pots to adjust red, yellow and blue levels. But you would need a 15 kHz VGA monitor. This is not a scan doubler. That's the Necroware real-time clock. I'm sure that will come in handy for a PC build at some point in the future. The Atari PS2 mouse adapter with PS2 port on it, and he included a DB9 socket, although I think I need to cut these studs off this to get that to fit on there. Need the PIC chip as well and something to program it with, so maybe look at doing that. Could be a handy little thing to have, because I only have the one mouse that will work on an ST. That's the one I've been using there, but it's also the mouse I use with my Amiga 2000. Speaking of Amiga things, there is the LED adapter. Definitely want to put this together because this would be very handy for when I'm working on a blank board. I assume I can just connect it to said blank board and get status of the 3 LEDs. Seems to support a 600, 500, 1200 and 2000. So very helpful little board. Back to Atari things though. And this is, I assume, the diagnostic cart, which might come in very handy for another future ST video. So I will look at putting this together. Need to try and find the bill of materials for it. A couple of resistors, a few jumpers by the looks of it. I would assume that's a ROM and some sort of logic goes there. Possibly a buffer or a bus transceiver, something like that. This, I assume, would just plug into the side of your ST into the cartridge slot. Last board then is this one, which is the USB-C Amiga power supply. So that might be interesting to put together and test out. Does seem to be quite involved, quite a lot going on here on this board. So again, I'll have to try and find the bill of materials, see about ordering up the parts that are needed and maybe put it together. They included the syringe as well. I'm sure it'll come in handy for something at some point in the future. So thank you very much, Gary, for first of all arranging the little group buy of the ACSI2STM and for sending on these cards. And well, there it is, the ACSI2STM. Still not sure I'm pronouncing that right. ACSI, ACSI, but regardless of how you're meant to say it, that is a fantastic little card. I'm not sure if we're using it to its full potential though, because well, it's got the 3 SD card slots. Obviously I'm only using one of them. So you could fully populate that, have different drive images on there or different partitions on there. And you can select what partition you want to boot to, for example. You may have noticed that when I was starting the machine up. But I just want this to run a few games. It is easier running them from the hard drive rather than running them from floppy or even from the Gotek. And so yeah, it absolutely ticks that box for me. I think the other thing that this will let you do is let you run GM-DOS. Now I'm not 100% sure what that is. I'm not that clued up on my STs, as you know. But I think it's maybe an updated operating system for these machines. Although, as I understand, it also breaks compatibility with most of the games. So for me, I'm not particularly interested in that. I just want to play a few games, and this definitely makes my life easier for doing that. Great little build. Frustrating little build with the 0402 components on it. So if you are thinking of getting one, what I'd maybe suggest is also downloading the pick and place files and the bill of materials from the GitHub along with the Gerbers, and then you can get your favorite PCB house to fit all the chicken feed for you, all those tiny little resistors and capacitors. The one thing though that this project has made glaringly obvious is that my ST maybe does need another upgrade. It maybe does need some additional RAM, because the 1 meg total in here, it just doesn't seem to be enough to make best use of this. So open to suggestions there. What could we do to further upgrade the memory in this? Yeah, I suppose I could just go out and get an STE, which natively supports up to 4 megabytes. And in fact, I do actually have an STE motherboard that needs to be repaired. But for the STFM here, is there anything that we could do to maybe bring it up to 4 megabytes? Or is that the limit? Could we maybe go further? Let me know what you think down in the comments. Let me know if you would have set up your ACSI2STM any differently. And yeah, that's going to be it for this video. So thanks for watching, and I'll see you next time.